So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. I hope you guys are doing fine. So we were doing section number 1, motion, forces and energy, and in our last lecture we have just wrapped up section 1.5, that is forces. So today we are going to start with section 1.6, that is momentum. Momentum, momentum, you can define momentum as that if an object having some mass is moving with some velocity, with some speed, then it is said to have momentum. Momentum is basically the product of mass and velocity or speed, whatever you want to call it. Its SI unit is kilograms meter per second or kilogram meter second inverse. It is a vector quantity because velocity is supposed to be vector. Hence, when you multiply a vector quantity with something, the resultant quantity is also vector. And momentum can be simply calculated with this formula. Momentum equals to mass into velocity. P equals to P is the symbol for momentum. P equals to mv. An object at rest when the velocity is 0 has no momentum. Momentum can only be calculated if the object is moving. Momentum keeps an object moving in a straight line or in the same direction. So in what you can say, if the momentum of an object forces it to keep on moving in the same direction. If you have to change the direction of an object, then you'll have to change its momentum, or you'll have to overcome its momentum. Now if an object with a greater mass is moving, then to deviate it from its path, to move it from its from the direction it is moving, you are going to require a very huge amount of force. Hence, object with a larger momentum, with a larger mass or with a very high speed are difficult to push from their path that they are traveling. Or in simple terms, you can say that changing the direction of an object with a larger momentum is very difficult. It is a vector quantity, hence it depends upon the direction, and as per the direction, momentum can be positive or negative. Momentum of an object will change if the object accelerates or decelerates, means if there is a change in the rate of its velocity, or if its direction changes, or if its mass changes. Objects with greater mass will have greater momentum, with the faster speed or acceleration will have greater momentum as well. Now here's an example question. What is the momentum of a car of mass 1000 kg traveling with a velocity of 24 kilometers per hour? Simply, momentum is supposed to be mass into velocity, so 1000 multiplied by 24 would give you 24,000 kilograms meter per second. Hence the answer would be C. Then we have another thing that is known as impulse. When an unbalanced force acts on an object, the momentum will change, creating impulse. Momentum is basically what you can say, a quantity that keeps an object moving, whereas when you try to change that, then you're creating an impulse, an effect, or the force you're applying on an object to change its momentum. That amount of per unit, the time that force is applied, is known as impulse. Impulse of a force is equal to the force multiplied by the time for which it acts. The moment a force is applied on an object in order to change its momentum, in order to change its direction, and the time for which that force has to act on that object to change its momentum, the product of these two qualities is known as impulse. Hence we write it as impulse equals to F delta T. Delta T means change in time, or the time required to apply that force in order to achieve our desired result, that is to change the momentum or the direction of an object of a mass. The change in momentum of a mass is equal to the impulse provided by the force. Hence impulse equals to change in momentum, and impulse is supposed to be F delta T or F into T, and since it is also equal to change in momentum, so we can say that it is equal to delta P. P is supposed to be momentum, so we can, if we put it into if we equate these two together, these two formulas together, then we can say that the change in momentum is supposed to be mv minus mu, means mass into final velocity minus mass into initial velocity. mv is supposed to be, v is supposed to be final velocity, u is supposed to be initial velocity. Now here's an example question. In a collision, a car of mass 1000 kg slows down from 25 meter per second to 15 meters per second. Calculate the impulse on the car. Now simply we know that impulse is equal to change in momentum, hence we apply the formula F delta T equals to mv minus mu. Since we do not know the time, we do not know the force, hence we cannot use this formula directly, F equal F delta T. So we would use the other formula, because we know that change in impulse is always equal to change in momentum. So impulse would be 1000 multiplied by 15, because that was the initial that was the final speed of the car, minus 1000, that is the mass, multiplied by 25, that is the final velocity, that is the initial velocity, mu. So 15,000 minus 25,000 would give us minus 10,000 kilograms meter per second, and that would be our impulse. The minus sign simply shows that the speed has decreased, or the impulse has caused a deceleration. Then we have something that is known as the principle of conservation of momentum. We say that, or in physics we assume that, in a closed system, the total momentum before an event is always equal to the total momentum after an event has occurred. Means all of the momentum an object had is converted into other form of energy, or into it is transferred from one body to another body after an event has occurred, or often in physics we take the examples of collisions. So the total momentum before collision is always equal to the total momentum after the collision. And a closed system basically means that energy within the system is constant and is not changed, and there is no there is an absence of external force. For example, we ignore friction, air resistance, or viscous drag. Thus, the total momentum before a collision is always equal to the total momentum after the collision, and we denote it as m1 v1 equals to m2 v2. This is the total momentum before a collision. This instead of f, this should have been I. Sorry for that. This should be I initial equals to m2 v2, and for final. As you can see, before the collision, this ball had some mass m1 and a velocity v1, and it is denoted with I, and this ball also had some mass and velocity. Once they collided, and after collision they separated and went into different directions, so this would be m1 v1 would always, all of them would have equal velocity, both of them would have equal momentum. Resultant force can also be defined the resultant force can also be defined as the rate of change of momentum on a body. If you want to know how much force was applied in order to cause the momentum or to cause the impulse, then that would be the resultant force. The change in momentum is defined as the final momentum minus the initial momentum that we have discussed. This is the change in momentum, mv minus mu, and we can also express it as follows. Force is supposed to be change in momentum divided by change in time, or we can say that this is supposed to be the momentum the final momentum minus initial momentum. Hence we would say m1 v1 final plus m2 v2 final, because this total gives us the final momentum of the system minus m1 v1 plus m2 v2 for the both trolleys, for both balls, for both cars before the collision took place. Now here's an example question. A trolley of mass 200 kg is traveling north at 2 meters per second. It collides with a second trolley which is traveling in opposite direction with a velocity of 5 meters per second, and they remain coupled together. Now remember one thing, collisions are always of two types. One is known as elastic collision, when two objects collide and then they both go into different directions. Another one is known as inelastic collision, when two objects collide and then they stick together and move in the same direction with the same velocity after the collision. Over here we have a case of inelastic collision. Calculate the velocity of the two trolleys after collision. Since the two objects stick together, they move together at the same speed. Hence m1 v1 plus m2 v2 equals to mass of trolley 1 plus mass of trolley 2 into final velocity. Before, one trolley was traveling at 2 meters per second and its mass was 200, plus one trolley had a mass of 500 and it was traveling at a speed of 5 meters per second. Both of these quantities together would give us the momentum before the collision. This would be equal to mass of both trolleys, as they have they are now stuck together, so they are now a single entity, so we'll simply add on their masses, multiply by the final velocity. Now this gives us 2900 and this gives us 700 v, as v is the velocity we have to find. Rearrange the formula, v would be equal to 2900 divided by 700, 4.1 meter per second. What is the direction of motion of the trolleys? That would be south, because the trolley traveling to the north had less mass and it also had less speed, whereas the trolley coming in opposite direction had greater mass and greater velocity, hence its momentum was greater, whereas the first trolley had less momentum. So once they collide and then stick together and move in the same direction, they would always travel in the direction of the trolley or the object which had greater momentum before the collision. Hence we would say the opposite of north would be obviously south. Another question, a trolley of mass 10 kg and a trolley of mass 5 kg are traveling in opposite directions, both at speed of 2 meters per second. Over here speed is same but mass is different. The 5 kg trolley rebounds at 1 meter per second, means after collision they both go in different directions, they both rebound. What is the speed and direction of 10 kg trolley? Momentum before equals to momentum after, m1 v1 equals to m2 v2. This was 5 kg and its speed was 1, so 5 1s is 5, whereas after collision the second one that is supposed to be of 10 kg, so mass is 10 kg, whereas velocity we have to find. But as momentum of both objects would be same, the net change in momentum would be same, so we would be using this formula, m1 v1 equals to m2 v2. Now 5 divided by 10 would give us 0.5, and since this is velocity we are talking about, so we would say 0.5 meter per second. That is it for section 1.6. I hope you have understood momentum. If you have any problems, any confusions, please do let me know. Like, subscribe and share my channel, and if you have any doubts or any issues, please do let them do write them in comments below. Do let me know whether you are finding my lectures useful or not, and I'll see you guys in the next video. Take care. Allah Hafiz.